Hey, welcome. This video is on solving systems of linear equations, and in this video we're going to use the substitution method. There's another video for the elimination method. All right, we'll get right into the procedure. Number one, solve one of the equations for one variable in terms of the other. What does that mean? That means get one variable by itself. Try to get either x by itself or y by itself, assuming that we're using x and y. All right, step two, substitute that expression. So one side of the expression, substitute that expression that we got in step one into the other equation. The result will be an equation with just one variable. The variable will appear more than once, but we're able to solve that. All right, step three, we're going to solve that equation. And then step four, we're going to use the solution that we just got in step three, along with the expression obtained in step one, to determine the solution of the system. So we're going to use the answer that we got from step three to find the second variable, and that'll be the solution to the system. I know, we see all these directions like, what the heck does that mean, right? We need some examples. So let's do it. Okay, solve the system by substitution. 2x plus 3y equals 2 and x minus 3y equals 10. So there's two rows. Our first step is to get one of the variables by itself. You could choose either row and get either variable by itself. Of course, we want to try to make it as easy as possible for us. So getting the x by itself in the bottom row would be our best choice. The coefficient of x is 1, so we don't have to worry about that. All right, so let's get x by itself. So rewrite the bottom row. To get x by itself, add 3y to both sides. So therefore we have x equals 3y plus 10. So now here comes the substitution part. We're going to substitute the x in the top row with 3y plus 10. Right? X is equal to 3y plus 10, so you go to the other row, which is the top row, and wherever you see an x, you replace it with 3y plus 10. Now we can distribute and solve that equation because there's only one variable in that equation. The only variable is y. It appears more than once, but there's only one variable. So distribute 6y plus 20 plus 3y equals 2. Add like terms. 9y plus 20 equals 2. Subtract 20 on both sides. 9y equals negative 18. And then divide by 9 on both sides. So we have our value of y. Now we need x. You could take that value of y and plug it into any equation that you want to. Any equation that has an x. You could use one of the two originals, or you could use the equation that we obtained getting x by itself, x equals 3y plus 10. I'm going to use that one, but if you want to use one of the first two, you can. So replacing y with negative 2, so that's negative 6 plus 10, and that gives us 4. We have our answer. The x is 4, the y is negative 2, so we write it in coordinate form, x comma y, or 4 comma negative 2. Put it in parentheses. Now we are done with the equation. We should check it. We all make mistakes. I make mistakes. So what you would do to check it is plug in the 4 and negative 2 into both equations. to make sure it works out. Okay, you don't have to unless it's required by the instructor. So I'm using the first row, 2x plus 3y equals 2, and I'm replacing x with 4 and y with negative 2. That gives me 8 plus negative 6, and we get 2 on both sides, so that looks good. One more. Now use the bottom row, replace x with 4 and y with negative 2, and then we get 10 on both sides. So you could feel really good about your answer. Okay, here's another one very similar to the last problem. You might want to pause the video and work it out on your own. All right, so we got to get a variable by itself. Probably our best choice is the y in the top row because it doesn't have a number in front of it. It's a 1. It is a negative 1, but it's better than another number. So let's take the top row and get y by itself. So subtract 3x on both sides. That gives us negative y equals negative 3x plus 6. And then divide each term by negative 1. That'll get rid of the negative. All the signs change. So we have y equals 3x minus 6. So now we need to take the right side of that equation and we're going to plug it into the other equation for y. Y is equal to 3x minus 6. So you go to the bottom row and replace the y with 3x minus 6. So I'm taking the bottom row. There it is. We put 3x minus 6 in place of y. Now we have an equation with only one variable, x. Distribute the negative 2. So that's negative 6x plus 12. Negative 2 times negative 6 is positive 12. And then combine like terms. 9x minus 6x is 3x. Subtract 12 on both sides. And then divide by 3. So we have our first answer, x equals negative 3. Now we need to find y. So take that negative 3 and replace it in any equation. I'm going to use the last one, y equals 3x minus 6. So replace the x with negative 3. That gives me negative 9 minus 6, which is negative 15. There's our answer, negative 3, comma, negative 15. Let's do a check. So replacing x with negative 3 and y with negative 15 in the top row, that gives us negative 9 plus 15. Whenever there's two negatives, it turns into a plus. And that's equal to 6. So we got 6 on both sides. We're good there. Now the bottom row. 9 times negative 3 minus 2 times negative 15. 9 times negative 3 is negative 27. And then 2 times negative 15 is negative 30, but there's already a negative there. So that'll turn into a positive 30. And we get 3 on both sides. So we feel good about our answer once again. All right, this one doesn't look as cool as the last ones, right? All of the variables have a number in front of them. So there's really no good choice. The only thing I would say is don't get one of the y's by itself, because then you have to divide by a negative. So then you have that negative hanging around. I would probably avoid the y in the top row and the bottom row because they both have a negative in front. So whichever variable you want to get rid of, well, let's start with that variable x, and it really doesn't matter between the top row and the bottom row. So let's see, what are we going to choose? I'm going to choose the top row. So let's get x by itself in the top row. Now, let's go through the process. There's a couple different techniques here. So first of all, this would be the same. Add 3y to both sides. So that gives us 4x equals 3y plus 7. Now we have to divide by 4. You could divide by 4 to each term separately, or you could just write it one time on the right side and make it one fraction. It really is just a preference. I tend to like just making it one fraction on the right hand side. Okay, so therefore I'm going to write x equals 3y plus 7 all over 4. Okay, now we got this equation from the top row or the bottom row? From the top row. So we're going to go to the bottom row and replace x with 3y plus 7 over 4. So take the bottom row, 3x minus 2y equals 6, and replace x with 3y plus 7 over 4. Now we'll multiply across that 3 that's in front. Think of it as 3 over 1. So distribute the 3 on top. That gives us 9y plus 21 all over 4. Now we have an equation that has fractions. Usually we don't want fractions, right? So we get rid of them. So we're going to multiply each fraction by the LCD, which in this case is 4. So don't forget the 2y times 4 and the 6 times 4. Now the first 4's, the 4 in the denominator and the 4 we're multiplying the first fraction by, they cancel. That's why we did this. The other 4's do not cancel because there's nothing in the denominator besides a 1. So we'll just multiply those. So we have 9y plus 21 minus 8y equals 24. Add like terms. And then subtract 21 on both sides. We got 3. All right, let's plug it into the equation to get our x. So 3 times 3 plus 7, that's 9 plus 7, which is 16. 16 over 4 equals 4. So our solution is 4, 3. Right, here's another one, very similar to the last problem. Again, you might want to pause the video. Here, it doesn't matter which row you're going to use to get a letter by itself. None of them have a minus sign in front, so no worries there. So I'm going to use the top row just so that it matches. Again, it doesn't matter. You could use the bottom row if you want to. But I'm going to get the x by itself in the top row. Okay. Now you might want to pause the video here and get the x by itself in the top row. And then come back when you're ready. All right, so we're subtracting 8y on both sides. That gives us 5x equals negative 8y minus 51. Then divide by 5. So now we have x equals negative 8y minus 51 all over 5. This is from the top row, so we're going to go to the bottom row and replace x with this expression. So it's 2 times negative 8y minus 51 all over 5 plus 3y equals negative 20. Distribute the 2 in the numerator, and then we got to get rid of that 5 again. So we multiply each fraction by 5. Everybody gets a 5. The 5's on the far left, those cancel. And now simplify. Negative 16y minus 102 plus 15y equals negative 100. Add like terms. A negative 16 and positive 15 is negative 1. So we'll just put negative y. Then add 102 to both sides. So that's positive 2. And then divide both sides by negative 1. So that gives us negative 2. Okay, plug that into the other one of the equations. I'm going to use the one that has x by itself and work that out. 16 minus 51 is negative 35. Negative 35 over 5 is negative 7. So there's our answer, negative 7, negative 2. Again, doing a check is up to you. If it's not required, I would probably just do it some of the time and then make sure I know how to do a check so that when I take a test, I am able to do the check. All right, a couple more problems, we're almost done. All right, let's take the top row. That looks like the easiest, right? And let's get y by itself. This one's a cool one. It's going to be a little different. Subtract 3x on both sides. Oh, we still got that negative. How do we get rid of the negative? Right, we divide all of them by negative 1. So we got y equals 3x minus 6. So replace y with 3x minus 6 in the bottom row. So distribute. Oh, this is odd, right? The x's cancel. And we're left with 12 equals 8. 12 does not equal 8. I could subtract 12 on both sides, but then I would get 0 equals negative 4. 0 still does not equal negative 4. So whenever the variables cancel and you have a different number on each side, then the answer is no solution. There's no solution to this equation. So what does that mean? Well, first of all, we got to write no solution. And you could also use that 0 with a slash through it. That's also a symbol for no solution. Graphically, what we're doing is we're looking to find where two lines intersect. Well, if we're looking for where two lines intersect and we don't get a solution, that means the two lines just don't intersect. If the two lines don't intersect, that means they're parallel. It's also called an inconsistent system when there's no solution. So no solution is the main thing to say, and graphically it's because they are parallel. Now, if you do get the same number on both sides, if you would have got 12 equals 12 or 8 equals 8, that would have been infinite solutions. How could two lines intersect at infinite solutions? Well, that's because they would be the same line. So they're exactly the same line. Not in this case. This case, they're parallel. All right, one more problem. Let's do it. Oh, interesting. One of them already has y by itself. Okay, cool. So we're not going to worry about getting a letter by itself because there's already one with the letter by itself. So we're going to go to the top row, and everywhere we see a y, we're going to replace it with 3 halves x minus 3. Distribute the negative 2. Maybe use your calculator if you have trouble with fractions. But negative 2 times 3 halves. 2's cancel. And we're left with negative 3x. And then the other one's going to be negative 2 times negative 3, which is positive 6. So we have 3x minus 3x plus 6 equals 6. The 3x's cancel, and 6 does equal 6. Therefore, the answer is infinite solutions. These are two lines that we have, and so what we're saying is that the lines intersecting have infinitely many solutions. The only way two lines can intersect infinitely many times is if they're the same line. One's right on top of the other one. So that means the lines are called dependent. They're called dependent when they're the same line. And I didn't mention it earlier, but when there's a solution like 3, 8, that's called a consistent system. All right, that's it for this video. I'll see you here for the next one. Have a good day.